Welcome and good morning, afternoon or evening to you all joining us from the United States, Canada, the United Kingdom, across Europe, the Middle East, Asia, Africa, or wherever you are in the world. My name is Marianne Dutka and I'm the Product Marketing Coordinator at Sealite, and I form part of our global marketing team. On behalf of Sealite, I wish to thank you for joining us today for our third Sealite webinar. Take this opportunity to sit back and relax for the next 45 minutes or so. This webinar is part 3 of a 5-part series where we are bringing to you industry-leading experts from across the globe. These industry experts will be sharing with you their knowledge and insights to assist you in the world of AtoN and risk management. Our topic today is AtoN Systems and Maintenance, presented by Malcolm Nicholson, our Global Product Manager for Sealite, and David Lewald, many of you will know from the US Coast Guard. David brings to us practical application from his career on the water with the US Coast Guard that spans over 30 years. David is delivering his presentation that will cover the past, present and future of navigation systems, and will take into consideration his role within the US Coast Guard in assessing emerging technologies and determining their feasibility for use. Before I pass over to Malcolm, I'll just quickly run through some housekeeping for those that are not familiar with the Zoom platform. So firstly, to view the speakers today under the View Options tab at the top of your screen. So feel free to ask any questions using the Q&A box during the webinar. And you can access that from the bottom of your screen and submit your questions at any time. We'll hold them all to the end and answer them accordingly. I now pass on to Malcolm, who will run through our webinar series.
Thanks very much, Marianne. It's a pleasure to see everybody out there, some very familiar faces and some who I look forward to getting to know. This is our third webinar in a series of 5, and if you happen to have missed the first 2, they are available on the resources tab on our website, and you can have a catch up. So I'm delighted to welcome Dave Lewald. He has a long and illustrious career with the US Coast Guard, many years at sea, and since coming ashore his delve into new technology and guidance, providing expertise in such things as AIS and INS, radar GPS, has come to the fore, and his contributions to organizations such as IMO, IHO and IALA have long been recognized, and he's presently the vice chair of the IALA ARM committee. So without any further ado, I shall hand over to Dave, and please begin.
Well, thank you very much, both Marianne and Malcolm and Sealite for asking me to be here today, and I really appreciate everyone taking time to call in. At the moment, I am attempting to take control of the screen here and see if we can bring up the presentation that I will be giving. And there, I believe I have control now. Thank you. Okay, so today I want to kind of talk a little bit about our AIDS navigation program in the United States and how we manage the system, how we perform maintenance, and I also want to kind of talk a little bit about what Marianne had mentioned about the past, the present, and the future. And I call that the AIDS navigation slide line or timeline, and basically how we can kind of move along that and move technologies and equipment along that timeline. I'll be relying on a lot of pictures to kind of provoke thought. I do have some slides, I'll warn you up front, that are very detailed, and there will not be a quiz at the end. I don't expect everybody to read the entire screen, but they are for illustration purposes. I do want to remind those that the US follows IALA, and specifically the IALA Region B. I also will tell you and warn you up front that I will slip in photos of the various ships that I served on over my time at sea. So the lower left of your screen there is Hickory out of Homer, Alaska. I actually had the honor of serving on board her twice. So the ACE navigation, like I said, we have this timeline. The center photo is just servicing of what was current a few years ago, the incandescent style lantern. And then the far right is a picture of Thomas Point Lighthouse, which is very, very close to where I live now and where I grew up. And I grew up oystering and fishing in the shadow of that lighthouse. So this has been program, or this work for me began in my childhood. So in a snapshot, the ACE navigation in the US is pretty much captured on this screen here. We monitor it very closely. Our office in Washington, D.C., we are the program office for the entire Coast Guard and the entire nation. The total numbers of buoys and beacons tend to vary from time to time, but right now we are hovering right around that 33,000 to 34,000 federal ACE navigation, and you can see the breakout of the buoys and the beacons. And obviously we are now moving into AIS AtoN and virtual AIS AtoN delivery. We currently have 52 permanently established, but at any given time, we have probably another 50 to even 100 virtuals used for recs and other short-lived, and these do not make it in. Those do not make it into our permanent records. Perhaps the most notable use of VAIS AtoN right now in the U.S. is in and around the Golden Ray, which was the car carrier that rolled over in Savannah Harbor. And it's in the process of being salvaged, and so we have it's 8 virtuals marking that work area. So our western rivers, our inland rivers, the Mississippi, Ohio, they are also separated from this national totals because these numbers of buoys really fluctuate weekly. And in fact, so much so that we actually create a data set and give it to the hydrographic office for our western rivers, the U.S. Army Corps of Engineers. The numbers of buoys fluctuate anywhere between 11 and 15,000. Really, over the last couple of years, we've refined that down to roughly 11 to 12,000. But we do have about 3,000 fixed aids that we build along the banks of the river. By way of example of fluctuation, 2 weeks ago, we had about approximately 11,600. And as of this past Tuesday, we had 11,200. And the reason why we had pretty much a 400 buoy swing there is that we're starting to see some of the buoys being withdrawn for the winter because we don't want to lose them to ice. So, and then lastly, we have roughly 40,000 private aids to navigation. The Coast Guard is the authority, for the approval authority, and we administer and provide permits to private entities to operate aids to navigation. So our primary method of our metrics, if you will, is for tracking purposes, our performance measurement is IALA's aid availability rate. This screen is a 10-year performance analysis beginning in April of 10 through January of this year. You'll see that we have several spikes along the timeline there. The first spike that we were doing very well, we were up near 100%. I have no idea what happened there, and it could be just as much as an administrative error as it could be a performance. And you can see that it was a very short-lived period of time. So that's one of the dangers of data, correct? But the lower spikes we can attribute to events, Hurricane Sandy in 2012, and roughly 2 really pretty serious ice years. But what's most notable about this screen is you can see the overall downward trend in our aid availability. And this is, it could be attributed to a number of things. Primarily, it is a budget driven decisions that we are deferring a lot of maintenance and replacement of aging structures. And so these structures now have failed, and we're trying to find the funding to replace those structures. So the aid availability is based upon, the aid. And when we have an aid go discrepant, an AtoN go discrepant, that counts against us. A discrepancy could be as very little as a small foam buoy that was blown off and we have to go retrieve it. And in the upper left, that's what you see. Obviously, it's in pretty shallow water, too shallow for the asset. So, you know, over the side, the fellows go to recover the buoy. Again, on the lower left, this is a unit I commanded in New Orleans. This is Pamlico, and Pamlico is a construction tender, and so it can build marine structures. However, in my 3-year tenure down there, I only built maybe 10 new structures. The rest of my time was spent responding and correcting damage to other structures, which you see on the right. This was a result of Hurricane Ivan. This was a rear leading light, excuse me. And clearly we had some work to do here. In my 3 years on board Pamlico, we had 7 major hurricanes, and roughly I had to build almost 4,000 or rebuild almost 4,000 aids during that time period. So we do track our discrepancies nationwide and by each regional office. We call them districts. District 1 is New England. District 8, as you see there in blue, that is the Gulf Coast of the United States, along with the Western rivers just to the north. You can see this past August, you can see our numbers were low, our aid availability percentages, and this was because of the record hurricane season that we had this year. A lot of the aids that were rebuilt early on in July were destroyed again in August. So the impacts you can see on the overall is relatively low. And if you look in the US, we've decided to break out our 3 types of AtoNs, Cat 1, Cat 2, and Category 3. These follow the IALA, Vital, Essential, etc. The vast majority of our numbers of aids navigation fall into that Category 3. And the reason for this is that we have opted to build in redundancy into our system. So each aid may not be as critical as others, but because we have so many of them, the waterway is still usable, and we typically can reopen a channel after a hurricane in a matter of days now. And there is a new piece of technology that we use to really speed that up, and that's AIS AtoN, and we'll talk some more about that. Okay, ACE navigation maintenance. It's an art, it's a skill, and it is obviously required. You must maintain your aids if you want to have them perform as function or as advertised. So again, on the left, you can see what we have here is we're building. This was actually my crew up in Alaska. This is we can build these structures ourselves using little jigs, if you will, and that's what the sailor is standing on. That's a gym pole that we can actually go ahead and build this style of day beacon. It's Alaska. The tide range is pretty extreme, and so we will go and we will work just before low tide happens. We build the foundation. We use rock drills, and we drill in, we place the foundation, and then it becomes a race against the clock and against the tide to get the whole thing done. It was always a bit of pride if you were able to do it in the 6-hour period and not have to wait out the next tide cycle. On the screenshot on the center top, this is a major construction. This is again, another rear leading light. This is on the Delaware River and the Port of Philadelphia, which is a major petrochemical port. The Delaware River freezes almost annually, and about every 5 to 10 years freezes very hard. And you can imagine the damage to our structures over the years and when we have these hard ice years. But this particular leading light is extremely critical. This would be a Category 1. And so we decided that we would go ahead and build a major structure that was ice resistant. So clearly this is not done by coasties in a blue uniform. This is done by a contract and a marine construction company. The picture below that, you can see that this is an older light that's been around for a while, but the foundation is beginning to crack. So we basically chipped away the old foundation, built ourselves a form, and replaced it. This is how we can get a structure to last, decades, if not 100 years. This particular one I looked it up, it's a 75-year-old light in New England. Today, we now know that a sleeping sea lion, it's not a good thing to wake up a sea lion out of a nap. And in past years, when I was young, we would just shoo them off. Now we wait for them to finish their nap. This is all joking aside, this is important. We need to learn how to build our aids, maintain our aids in harmony, not unobtrusive. We do have areas where we have floating buoys that are in coral on other sensitive surface, or excuse me, bottoms. And so we need to look at environmentally sensitive moorings, etc. And this is important. We'll talk some more about this as we go through. On the upper right, this is a training facility. This is our tower climbing, and I want to get into training next. And I like this picture. This was actually several members of our office a few years ago. We discovered that we had some bad positioning information on our leading lights, and we needed to resurvey them. And this was a little bit beyond normal, crew capabilities. So we all had to go through this tower climbing class. And the first time I went through the class, I was a lot younger. I was still the youngest in this class, but I was 52. So it was kind of a lot of fun to watch a bunch of guys look like me, hanging from a tower. So that tower is located at our National AIDS Navigation Training Schoolhouse. It's in Yorktown, Virginia, and it has a whole slew of courses they offer in addition to the tower climbing. They basically have classes from the commanding officer of a unit all the way down to the technician who is working on the optic or whatever. It also has a deployable school. So in other words, they can come visit you at the units, and there's exportable training. We do a buoy deck training evolution. We do a construction tech training evolution. So those are all exportable classes, or like I said, you can go in and have in-person classroom. The one area that we are now looking towards is the training of our waterway managers and our senior AtoN people. And we really don't have that. And so over the course of the last year, I have taken the IALA AtoN Manager course, and I am currently taking the master's course, AtoN Management Master's course. They're very good. This is my plug for the Worldwide Academy. They are very good courses, and I highly recommend them. And we are looking to join with Canada to perhaps maybe on even in odd years, host classes and then open it up to Canada and vice versa when Canada hosts it. So we have, like I said, a very robust training program, and that is absolutely necessary to be efficient and effective in maintaining and establishing AtoN. We also have a slew of manuals and service guides and field guides. On the far left is the front page of our cover of our AtoN structures manual. In this manual, we talk about, how to inspect a structure, what to look for, what are signs of decay, etc. The next one over is the short range aid to navigation servicing guide. This is actually a small little flip booklet, if you will. It's a pocket guide. And it's all laminated pages, and it's meant to be thrown in the back of your coveralls, and when you get ready to go service the AtoN. This is the brainchild of one of our just phenomenal engineers that we've had working for us over the years, and he's since retired, but some of you may have heard of John Grasson, but truly a pioneer in the US AIDS navigation. The next item over is just actually a page from that, and it's just a simple line diagram of the old incandescent. Here's your lead acid battery, and here's your solar panel, your flash controller, your day-night control. Again, this is a great little manual. But in my duties, looking at new technologies, I got to look. This is to the far right here. This is a Google Glass. Now, how cool is that? Think about having all of these manuals and these service guides right there in your Google Glass. And if we could pair that Google Glass with a tablet or a phone, when you really get stumped, you can actually hold the camera up, phone a friend, and actually get some technical guidance. And I'm going to give them Malcolm's phone number whenever it's a Sealite thing, so they can call you, Malcolm, and ask questions. So So, on the far right or the far left is, the old printed, manual. And now it's, we're modern. It's in PDF form, right? But all the way over here to the right, maybe Google Glass or something similar to that would be useful. Okay, let me go ahead and get right into how do we determine how often we need to visit an AtoN. And to make that determination, we have developed a series of questions. And we call it the servicing interval flow chart. And from these series of questions, we can develop how often and when we need to service an AtoN and perform maintenance. And it really comes down to if it's a buoy, the chain, the mooring. If it's, if it's got a light on it, what's the battery source? What's the power source for this? And are there any other unique considerations? And so from that, we develop an interval. And right now, for a buoy, an interval will not exceed 3 years. Same thing with a light. It will not exceed 3 years. An unlighted day beacon, or a beacon, if you will, we can push out to 5 years. But we're still finding that more times than not, we go and there's nothing wrong. All we've done is make sure that, we feel better. We didn't really do much. We might brush some guano off, or we might get rid of some ring growth. But other than that, there's not much done. And when you think in terms of, a big ship visiting an offshore buoy, some costs can get expensive. On each of our visits, though, we do generate some paperwork. We have what we call the Federal Aid Information Document. This is the piece of paper that has everything about that AtoN, all the equipment and the hardware, etc. And we go through that. This helps us service the aid, but we also validate the information on this so that for program management, we can understand what is in the field. What do we have out there? And I'm going to draw your attention to the center page in the lower bottom. On the left-hand side of that center page in the bottom that's all about the buoy, what kind of buoy it is, what type of buoy, and other information. And then to the right, this is all information about the mooring. So from a program point of view, we were having a lot of incomplete data, especially as it related to the mooring. Specifically, on the right here, the number of shackles in a mooring. A large shackle is not cheap. And when you have a minimum of 5 shackles for a buoy, most buoys, we're starting to get that. But if we don't capture that in the database, we really have no idea how many shackles are in the field. And as crazy as that sounds, when we're talking tens of thousands and we're competing for funds with other programs within the Coast Guard, we need to be able to, gone are the days where I could just say, trust me, we have a lot of material in the water. I now have to get down and be able to count to the shackle level. Also, we create a positioning record every time we visit a floating aid and whenever we establish a new fixed aid. And we use a GPS for this. The upper part of this report, you'll see these are the NEMA strings from the GPS. And then the lower gives you some of the environmental conditions and what was going on, where the vessel was pointing, etc. Between all of these data fields, we can 100% recreate the fix and basically prove that this is in fact where we put this buoy when we left it. So we learned through some not great court cases in the 70s that we needed to be better with this. And this really is where I put my teeth into a lot of the work that you see here. It was work that I first did when I got into headquarters. When they benched me, when they took me away from sea duty, they put me in headquarters. So I've been serving my penance ever since. So remember that screen that I was showing you with the buoy data and the mooring data. When you're in our IT application on scene working this buoy and you go to edit the mooring, this is what you see. Now, it is accurate because it shows you not only this line diagram of what this 7 by 17 buoys looks like, so we can make sure that you can just look out your window and say, well, that doesn't look like what I got alongside the ship. So we saw an instant improvement in data just on the on-scene haul alone, just by showing this picture. It's hysterical, but bear with me on this. But as I mentioned, the shackles were something that we just did not have a handle on what was in the field. And so we put this screen together, and this is a live screen. Unfortunately, this is a still shot, but you'll see when I click here to the next screen, if you were to remove any segment, or more importantly, do not have a piece of the required piece of chain or mooring in place, the mooring would collapse and fall to the bottom. And so because the business rules and intelligence behind this application, it knows that this 7x17 buoy needs to have a bridle. And to connect the bridle, it needs at least 2 shackles. And then below that bridle, you have to have a shackle to a swivel, and then another shackle to your chain. And so in this particular instance, the shackle is what's missing. And so from that very data dead report that I showed you, that visually dead report that I showed you, now we have this visualization tool. And what we found is when we rolled this out in 2014, almost overnight, our data quality went from about 10 to 20% to 50%. And then over the course of time, we visited all of the aids, and it's 100% now. We know what we have in the field, and that's been a phenomenal success for program management. This is actually the screen from this software that I'm talking about. And up here in the upper left, you see this red number 5. This means that there are 5 failed business rules somewhere in this report. And if this were live, I could click on it and show you, it would take you and show you what elements are missing. Nowadays with the internet, you can't order a product online unless you fill out all the forms in the credit card, right? So we've kind of adopted that as well. We want them to make sure that all the fields, the required fields, are filled out. And then under this bell here, we call this warnings, and we have a nice little yellow or shade number that would pop up to say, okay, we want you to fill this out. We're not going to prevent you from completing your job today, but we want you to fill this out. So this alarms and warnings has been very successful, and over time we've watched our data quality improve. One of the other items that is mandatory that we track are our batteries. Batteries are a hazardous material, and in the reportable quantities that we have, we are required to track all of our batteries, as we call cradle to grave. From the moment we purchase it, we cycle it through our storage areas, and then we install it on the AtoN. We remove it from the AtoN, at the end of its life, service life. We put it into storage, and then we recycle it. And we have all of that data and all of that documentation to follow it. So this is a battery tracking feature within the application. Again, moving from where we were, where we just threw away batteries. Now we actually track them, and we make sure that they are recycled. Okay, so on the upper left, you'll see my little my timeline, my timeline, where we have the legacy lighthouse. We have the buoy, and always wanting to keep an eye on the future. What's coming next? And so I tried to grab some visual pictures here for you of different things that follow along. The lower left, we have the schematic of a lighthouse, and a lighthouse that we are still operating. Above that, we have some Sealite products that are all completely self-contained, and these particular ones, the one in the center is an AIS combined lighted AtoN. So we all know the Fresnel lens here in the center. This is a particularly beautiful one. There are not many folks left in the U.S. Coast Guard that are lampists. I was trained early on in life, but I don't think I could do it today. I would have to really break out some of my old notes and then think about the lighthouse, that Fresnel lens, and then you look at the things like port entry lights and really where we've come and what we're able to do now. And a degree and a half of arc on a light. Are you kidding me? This is stuff that we only dreamed of, just maybe even 2 decades ago. So on the upper right here, this was the optic that was still in use, but starting to be phased out when I first came into service. And this used a primary battery that had a rated battery discharge of roughly about 180 days of life. And we had to basically go around and recharge these things frequently, every 5 to 6 months. So to have a lighted AtoN then was a big deal. And we needed to decide that we were going to commit not only the cost of this, but the unit to service it. Now on the left here, we have this again, another Sabic product, but here's, this self-contained, these, I expect these on a normal latitude, we'll see 8 years. I mean, and battery technology is kind of like cell phones, I mean, they're just coming through with breakthroughs, annually now. And so really, it's incumbent upon us as AtoN managers to really kind of keep an eye on this and really start to think about, do we need to really go back and visit an aid every 3 years like we do with our lights right now? What are we accomplishing here? What are we expecting to find wrong? So we'll touch more on that. Okay, buoy hulls. The Coast Guard primarily still, our offshore buoys are primarily still steel, and we have been slow to move into the non-ferrous ideas out there, like you see on the right. But our platforms are designed and built to lift this, the steel hull, and when we encounter a buoy shape that's slightly different than what we've been trained on, again, there's that training piece, we kind of hesitate. It's not that we're afraid of the new or the unknown, it's just that our deck evolutions are still geared towards this steel hull. The picture I have here is actually kind of neat. This is a buoy that we looked at using nuclear technology on. It was in the Port of Baltimore in the early 60s. And so again, it's not that we're afraid of technology or new ideas, but yeah. But what we decided about this nuclear buoy is that it's a marine environment, it's being picked up by a ship. Yikes. I don't think the crews are really excited about working this buoy. And there wasn't a long list of volunteers, that's for sure. And lastly, when it comes to buoys, is the mooring. And this still is the weakest link, in my opinion, on servicing intervals anyways. And the heaviest maintenance lift that we have today is the life expectancy of a mooring. On the upper right, you see that the chain, we still have mountains of chain in our buoy yards around the Coast Guard. It still is the mousetrap of our choice right now. But we do need to start looking seriously at more of the synthetic moorings, not only for life expectancy and being able to push out that servicing interval, but as I mentioned earlier about the coral bottoms and everything else, a lot of these synthetic moorings do less harm. And again, being stewards of the environment, we really do need to concentrate more on that. So our R&D center in Connecticut has been doing some synthetic and least or less damaging moorings, and we will continue to look into this. But from a management point of view, the mooring is still our weakest link in terms of being able to push out that servicing interval. So today, the U.S. Coast Guard is considered a publicly monitored system. And so we wait to be told that an aid is not performing properly. Now, obviously, we've told all of our Coast Guard units out there operating that they better report. But we really do wait, and that's why I have the photo of the mariner in the lookout. Let us know so that we can fix the aid. But with new technologies, we are now expanding and beginning to research and do some testing with monitored AtoN. Now, we did have monitored AtoN way back in the 70s and 80s. And when we first started to unman our lighthouses, we were nervous about that. So we did put in systems that would monitor the light. Those systems have they've not been maintained, and they didn't really tell us much. So we kind of abandoned that in the 90s. But now we're starting to look at both cellular, GNSS, not GNSS, excuse me, cellular, satellite, and we have recently purchased several lights from Sealite to take a look at their Start at M, their monitoring service. And we have actually next week, 2 are scheduled to be placed into buoys in New York Harbor. So the first 2 will be going out next week. Pretty excited about that. And this will be a long-term study, and we will be looking at how to bring in monitoring systems such as Start to M into our our tool bag. Okay, I want to talk now. I want to shift a little bit on you. Proper management, program management really does rely on software these days, and our software that we currently operate is actually broken into two pieces. We have our legacy AtoN system, which was turn of the century capability in software design, and we all now are transitioning to what we call the US AIMS, or the US AIDS and Navigation Information Management System. We were full speed ahead on transitioning beginning in 2012, and we ran into just a major blockade, and that is that the US government needed to shift and really harden all of our IT systems for cyber. And that's not just the US, I'm sure it's around the world. We are now coming out of that, and we are restarting and reworking our continuing the transition into US AIMS. We have had a very recent development in that our office, our hydrographic office for our coastal waters, NOAA, has announced that they are going to discontinue their paper chart production. Our database and our management system is predicated or based upon chart numbers and chart additions, and so we're really now having to quickly retool and shift our emphasis, and we're going to adopt what we call a waterway or harmonized waterway approach. So no longer are we going to refer to a chart. We're going to refer to a specific waterway, excuse me. And we're going to use the MRN, the IALA MRN domain management and numbering of those waterways, pardon me. So I love this drawing. I did this in 2012, half to impress my wife and the other half to actually explain what it was that we were trying to do with the modernization of our IT management. And when we sat down, we realized that AIDS navigation management had a lot of tentacles. It touched a lot of the maritime community. And so everything from reporting our positions and operation status, et cetera, to recovery from a hurricane, to providing field commanders decision tools, risk analysis, all of these pieces. And I know Roger spoke heavily about risk analysis in your last session. We really want to pull in a lot of the goodies that Roger has been developing into this, so that it's seamless. It's part of our thinking day in and day out. So yeah, this is just a mind map, but again, I love it because it really does illustrate just how much we expect our database and our IT solution to cover. Again, I'm going now really shift gears. Remember, I just mentioned about waterway, harmonized waterways and waterways approach, and looking at the system from that perspective. What I'm trying to do is really kind of shift our thinking away from individual AtoN, this buoy, that buoy, and I want to look at the AIDS navigation system as a whole within a waterway. And so to do that, we are developing what we call our Waterway Analysis Management System, a WAMS. And what we expect WAMS and what we expect US AIMS to ultimately do is provide all of these blocks. The first primary blocks of program management, waterway management, marine domain awareness, and marine safety information management, and then all the pieces off to the side. And so we want to take that holistic view of AtoN and how AtoN affects and how we can manage the flow of traffic through a waterway. Let's face it, the ships are getting bigger and deeper, but the channels aren't, so we really need to be really stepping back and thinking about how we do business to keep that economic engine flowing. So this is it. This is WAMS. This is what we wanted to do. It's going to have 4 major sections. We have waterway health. That's the snapshot of today, right? How is it today? I call this the morning brief piece of the WAMS. We have 5 discrepancies, but we also have an LNG, a liquid natural gas ship movement coming through the same area, these 5 discrepancies. So maybe our urgency needs to go up a little bit to try to correct at least the most critical of those discrepancies. We have waterway performance. And in waterway performance, we really want to kind of look at the waterway health, but we want to look at it over a period of time. And we want to look ahead to say, you know, this one structure is getting kind of old. You know, if we lose this structure, what would happen to the, you know, the overall health and the performance? So we not only do we want to look back in time, we want to kind of move and be able to forecast what our condition would be. And then the next piece is the waterway trends and analysis. You know, let's look at what's going on in our waterway. We have tools now. We have AIS. In the US, we have a nationwide infrastructure of shore-based base stations that really kind of track and can tell you where the density of traffic is, and we can even look at where shifts in you know, shifts in vessel size. Maybe we have other data sets that tell us what's in those ships, the cargo. We have data sets that tell us the condition of the channel. Is it shoaling? Is it not? You know. And then we want to bring it all together into that last piece, waterway design. This is where we, you know, this is where the dream is realized, if you will. This is where we will actually, I call it the needle. We want to keep the needle here in the center. This is, you know, this is a dangerous situation, and this is excess capacity, you know, too much AtoN, right? There is such thing. So we want to keep that needle here, and that's where we're going to do it in waterway design. And this is going to allow us to tabletop, you know, hurricanes. That allow us to tabletop if we're going to lose a servicing unit for maintenance for a period of 3 or 4 or 5 months, you know. So this is where we really kind of keep the finger on the pulse of the US AIDS navigation system. And so I use the standard, you know, Roger will appreciate this, you know, the risk folks, you know, the green, yellow, red. The green is the AtoN. That's what we know. Okay, we have it in place. We're trying to flow traffic through. And then the yellow, that's your oddball. That's your marine events. That's your regatta, right? You know, you have a regatta going right through the middle of the channel. You know, we need to know this. We need to be able to accommodate this and handle it. And then the last, of course, is the red, is the unknown. You know, what happens if we have a hard winter or a heavy hurricane season? How do we deal with it so that we can practice dealing with it before it happens, and so that we can have our war game, if you will, and then follow it up with some action plans that make sense. So just by way of example of what I'm talking about, when we were doing our proof of concepts for development of WAMs, we gave it to a contractor and we said, all right, this is kind of what we want to do. And they're a very talented bunch. And they came back with this visualization of AIS data. This is on the eastern shore of the Chesapeake Bay. And it is, what you're seeing here is 2 hotspots. And what we found is that these are tug and tows full of home heating oil. We're loitering, waiting for proper conditions to go into those 2 rivers. This particular part of our country, the highway system is not sophisticated enough to handle the amount of trucks it would take to get all that home heating. Marine traffic is the way to handle this. Marine transportation is the right way to ship all that home heating oil. But by golly, this was a jaw dropper for all of us, those 2 hotspots. We did not know this was occurring. And now we do, and now we can take steps to mitigate the risks here and move forward, and perhaps you know, having a barge in home heating oil just loitering out there waiting is just not it's not what we want. And again, so this was a oh my gosh moment for us, and this is why I think our WAMs is really going to be a watershed for us. And that's it. That's what I have today. Oops, it went back. And I thank you for your time, and I really look forward to a discussion.
Thanks very much, Dave. What a fascinating insight into the US Coast Guard's world and how you've dealt with these things over a period of time. We've got time for a few questions that have been coming in while you've been talking, which is fantastic. And it's actually something I was going to ask as well. But we have a question from Sarah Robinson. And essentially it is, could better knowledge of AtoN availability due to improved system explain the downward trend in availability, which I totally concur with. The more you find out about a system, the more you find that you're not compliant, if you like.
Yeah, you know, well, hear no evil, see no evil, right? In the U.S., we consider if we were to lose the optic, we consider that a total loss of 24 hours versus just dark. So we are a little bit overcritical on ourselves, first of all. So, but that was a programmatic choice. We said, if anything's wrong with the AtoN, everything's wrong. So right off the top, there's that. Yes, the more we know and the more we study and the more we train, again, like I said, we're a publicly monitored system. The more we make it easy for people to tell us what's wrong, the more we're going to hear. I have a quick sea story for you. I had a light on the backside of Kodiak Island up in Alaska, and we serviced it every year. And we went out in July and we worked on it, and we went out the next July and we went back and we worked on it, and we found out that the technician forgot to reconnect it, and so it was extinguished the whole year, and not one report. It's embarrassing, but that is truth. So I think I would just agree with your statement more than answer your question. I think you're right.
Yeah. So when do you think so your impact, and it's great to see the development over a period of time from AIMS and into WAMS. So when are you expecting to see the benefits of implementation of WAMS?
Well, I think we'll see it straight away. And clearly, what we did when we found that hotspot, if you will, we instantly turned on synthetic AIS AtoN on every one of those buoys going into those rivers. Because what we were told when we talked to industry is that because of the winds and ice, these buoys were not reliable in the winter months. So, very simple solution was for us to start to broadcast synthetics, and we already saw a reduction in those loitering times. So I think that it's going to be instantaneous. As we roll these things out, our people will learn how to use them quickly. So.
Now, a little bit of time to put you on the spot with some a bit more practical questions, and it's a really good one that often comes up at IALA as well. The advantages of using cast iron over concrete, or vice versa. For
moorings. For
sinkers, yeah.
Yeah. So we back in my early days, we had a spherical or half sphere shaped steel sinker, and that thing, and it was concave underneath, and by golly, when that would get in the mud, it wouldn't move, and very rarely could we ever even break it free. And the joke was, it was in the Delaware River. The joke was that it was working its way to China, and we literally just would pull it tight, and then we would have to add a little bit more chain about every 2 or 3 years, just because it was still sinking. Wow. So I think they're fantastic. I think that the cost is the issue. But having said that, our smaller sinkers, we use Dormore sinkers. It's a type manufacturer, and it is an upside down pyramid, if you will, with a mooring attachment. And they are very good. And those are fairly cost effective because it doesn't take up as much room on our small boats. So we have been using steel for our smaller buoys. And in that one photo I showed you, that was most definitely used, a Dormore, a steel sinker was used on that small buoy.
And I suppose nowadays, really, as well, more the environmental concerns of using concrete.
Yeah. I will say that we have been working with environmental groups over really several decades now. We've been using our old sinkers as materials for them to create artificial reefs. So we're not throwing them in a landfill. We're working with our National Marine Fisheries, et cetera, and we are using our old concrete for that purpose.
It's a bit of an off-the-cuff question from an anonymous, but how many batteries do you think you go through on an annual basis?
That is an off the cuff. Yeah, it's considerably less now that we are going to LED. So it's not so much the battery; it is the optic, right?
Yeah.
So, and then the self-contained has just really been a game changer for us. But primarily the LED, because it just doesn't take as much power to operate. On that big old buoy that I showed you, that we had the atomic power source in it. Those buoys would hold up to 8 100 amp hour lead acid, and we would have to recharge that every 6 years. 5 years. And over time, that's a lot. since we've been making the shift to LED technology and self-contained, what do we have, about 20,000 lighted buoys and lights? I would say probably less than 15% of that inventory is changed out every year. Let's not, but we do lose a fair amount to hurricanes, etc. So,
yep. And I suppose that leads on really to a question from Terry. The capital that you put in to initially buy the AtoN, does it outlive its life cycle? And I suppose you've almost just answered that with the advent of LED technology, and that it does.
Well, you recall that I mentioned John Grasson. John Grasson was the one who really kind of figured this out. He set the price point for LED. So when we took our jump into LED, it was because the cost had come down, and it made sense to do that switch. The Coast Guard, we operate ships for 70 years, with the life expectancy when we originally buy them, that we were told is 30 years. I showed you photographs of guys chiseling away the foundation and building a form and repouring the foundation. Same thing with our buoys. Our steel buoys, we say that they have a 24-year life cycle, but what we have found is that they go well beyond that. And we have a very significant criteria that they go through every time we pull them out of service and put them through the rehab. It has to pass an inspection. And what we have found is, because we do routinely pull them out of water for maintenance, that we're getting more than our thing. So it's a kind of an old number, and I really am hesitant to throw it out, but our annual funding is really for materials, it's less than 300,000. It's not a lot. It's the infrastructure supporting it. It's the ships. It's the people. Yeah. That's where the money comes in.
Yeah.
But we're pretty good at stretching a buoy out. We'll get a lot of service out of it.
Yep. I think Mary Ann's given me the hurry on, but this is such a fascinating topic. I think we've managed to squeeze a couple more questions in. Theft and vandalism. Do you have a problem with it, and how do you manage it?
We do, and there's really not a lot we can do about it. I mean, a motivated thief is a motivated thief. So I can't tell you how many times working in Louisiana that I would be cruising downriver and I would see a homemade shed with our day boards are the walls. So like I said, a motivated theft is obviously. It's a cost of business. Really, we could put locks on gates. We can do things of that nature. But again, short of putting cameras and alarms and whatnot, but we do. We have a lot of vandalism. For some reason, people like shooting at our booth. It is America, I guess.
Yeah. Okay, I think we've got one last question. Where was it? More to do with training. There's a couple of questions coming in with regards to training. How long's the training program, and do you offer courses outside, which is quite interesting.
So the training, the length of the training really relates to what the training is. We have seen a reduction in the amount of time or amount of days that we need in the classroom because of technology. Our aids to navigation positioning software has really improved. So what was a 19-day course is now 5 days. Really, that happened over the last decade. So we've improved that. We have brought in other countries, aids navigation professionals from other countries into and put them through the training. We have berthing and housing right there on our base in Yorktown if you want to take advantage of that. And if anybody is interested, unfortunately I can't open it to just anybody. I can open it to a government, and we can do perhaps some sort of agreement to bring you in. But it has happened in the past, and we all benefit from that when we have outside perspectives.
Mm-hmm. Well, I think we're going to wrap it up there. Any unanswered questions we've got, Mary Ann and I will do our best to answer them. Of course, you can always email us at Sealite, and we'll be able to answer your questions. The next webinar will be in just a couple of weeks' time, actually, 10, 11 days' time, which will be, our guest presenter will be Francis Zachariah, who is on the call. Hello, Francis. Good to see you. And I'm sure Geraldine from the Academy appreciated your plug as well, Dave. So we're really, really looking forward to that one. And Francis will be talking about the history of IALA, how it works, where we're going. I'm sure he'll mention the Academy and where they're going forward. So we're really, really looking forward to that one. And if you would kindly take a few moments to fill in the survey after we finish up here, we'd really, really appreciate the feedback. It's been great to host this and have this. Thank you very much again, Dave. And we look forward to seeing you in a couple of weeks' time. Thank you very much.